The first distribution is Poisson process. Poisson process satisfies the following properties. The first is that x of t can be expressed as Poisson lambda t, and this process is often used to count the number of occurrences of an event from 0 to t. And the second property is that x of t2 minus xt1 is also a Poisson distribution, and if we have disjoint intervals t1 to t2 and t3 to t4, and if t1 to if these two intervals has no intersection, we know that x of t2 minus x of t1 and x of t4 minus x of t3 are independent. And furthermore, xt2 minus xt1 is also a Poisson process, and if xt is a Poisson process, and so we can find that ext is lambda t. So the expectation of the process is dependent on t. So we can say that it's not a y-sense stationary process. And RT1 autocorrelation RT1 T2 is lambda square T1 T2 plus lambda mean T1 T2. And the second process is Poisson increments. The definition can be expressed as yt is equal to xt plus c minus xt over c, where xt is a Poisson distribution, and the expectation of yt can be expressed as eyt is equal to 1 over c ext plus c minus xt, which is equal to 1 over c multiplied with lambda c, which is equal to lambda. And ry t1 t2 is equal to, from the definition, is equal to t y t1 y t2. So we can divide the situation into two parts. The first part is that if t1 plus c is less than t2, so the r t1 ty t1 t2 is equal to lambda square, and if t1 plus c is larger than t2, so the rt1 t2 is equal to lambda square plus lambda square over c minus lambda t2 minus 1 over c square. And the last process is normal process. If xt1 x to xtn is jointly normal for any t1 tn, so we can say that this process is normal process. The property of a normal process is that the statistics of a normal process is fully determined by these two equations. The first is that the expectation is equal to and the expectation of the autocorrelation is equal to RT1 T2. And if the process is a normal process, we can see, if we find that xt is a y-sense stationary, we can find that xt is also a strict sense stationary. And